All right, welcome to the MonaK Academy. I know we tried to do this beginning of January, but hey, I underestimated the need for having a good time. I mean, trying to make students study just after Christmas and New Year was like a bad idea. But it's now time. There's no more delay. Even our public institutions are starting today as well. So let's get right into it. So today I am going to be working with grade 8 learners. So anyone who is doing mathematics in grade 8, you are at the right place. So before we start, let me just say, give a shout out to all our sponsors. You can see their logos. I won't be able to mention all of them, but just check. I think the second screen after the one for socials. Yes, you can reach me, the MonaK Academy, via YouTube, which is the MonaK Academy. On Facebook, it's the MonaK Academy. On Instagram, it's also the MonaK Academy. So before we dive into the maths, some of you might be wondering, Everson, what qualifies you to be standing right in front of us and telling us that you will be able to teach us and help us get A's? All right, I've got two answers to that question. So the first answer is, I've been teaching for more than 14 years. But I know some of you will be like, yeah, that's what everybody says. Everybody who wants to teach or who wants to offer extra classes will always tell you they have all this experience. So maybe we can try another reason. So the first one is what I managed to do when I also studied in high school. So maybe that can give you the confidence that I know what I'm talking about. So this is my certificate for Zimbabwe school, high school. So my exams were in 2002. That was ordinary level. So as you can see, looks pretty okay, right? So probably, because you see this, maybe you believe that I'll be able to help you. All right. If that is not enough, let's try my university days. Okay, so while I was at UNAM in my final year and other years, this is the award that I got for Best Financial Management Student from the UNAM Accounting Society. Maybe you will say that will qualify me. If that's not enough still, we can try that. That's another certificate. This one, it's from Deloitte and Touche. So this one is, again, Best Financial Management, 93%. All right. Enough about me trying to convince you that I can be able to teach you. Let's just put it to the test. So for the next 40 minutes, we are going to be looking at mathematics. So my approach, I've developed this system over the 14 years that I was talking about, that I've been teaching, and I call it the step study system. So there's nothing so special about the system. It's just that it works, right? So why and how does it work? So all the way from a detailed video, we will see it on the link right there. Here I'll just briefly describe what the step study system is. All right, so all the way from the time you are maybe grade 1 all the way up to high school, you are guided by a syllabus. That's what helps the teachers prepare for your lessons. Every teacher, everywhere, they have to know the syllabus so that they know what to teach you. So because everything is guided by a syllabus, we call it a standardized test, right? They can't just bring questions from Mars or from another planet. It has to all come from the syllabus. So that's where the secret is. Because if all the questions come from the syllabus, then what does a clever student do? A clever student just goes to the syllabus, looks at what the syllabus requires, and learn everything that the syllabus requires. Sounds easy? Because it is. So we'll use the step study system to do all the subjects that we'll be doing at the MonaK Academy, right? So you will have the syllabus, you will have the textbook, then you start doing exam practice. And I encourage exam practice to be done immediately after every lesson. So if I have to show you how the system is going to work, this is how. So this is the syllabus for junior secondary phase for mathematics. So remember, each subject has its own syllabus. So if you are taking 8 subjects, you will be able to access all the syllabuses for all your subjects. This is the textbook, so you'll be able to download this book as well, right? So it just matches what the syllabus requires, so whole numbers, integers, exponents, and all that. And then immediately after our lesson today, we'll look at which questions from the exam paper. So this is like a specimen exam paper. So which questions from the exam paper are we able to answer based on what we've studied today so far? So that you immediately know that it's doable and you'll be able to do it in the exam. You don't have to wait until end of March to start looking for past papers and then start figuring out if you can do it. As soon as you finish every lesson, practice some question papers and continue to practice. That's the winning formula. If you just do that, follow that, you're done. All right. Next. So instead of going to the whole textbook like this, I'm going to be simply, I'm going to close that because I summarized everything here. So I took out most of all the concepts that are required in the syllabus and I put them on this worksheet. So you'll also be able to download it. The link is also just down there. Okay, now this one is on down the description of the video. All right, so it is the MonaK Academy. Even if you search on Google the MonaK Academy, search for the result that says teachable. So let's see, when you go to the MonaK Academy, this is what you get. This is the website. So from here you'll be able to navigate to, if you say view courses. All right, so let's see. All right, so there is the learner's course. Then you have to register first so that you have access to all the books, the calculators, and every other resource. So it doesn't matter whether you are doing maths or accounting, you have to register. All right, so when you come and click here, this is what you'll be able to get. All right, this is the registration page. So as you can see, your syllabuses will be here depending on your grade. Your textbooks will be here depending on your grade. And your calculators will be here. Some more stuff. And then here, where it's written library access, you will have access to more than 6 million books by registering and accessing our library, right? So for now, until Valentine's Day. Okay, this was a gift from my Mona. She said, please, until Valentine's Day, just keep the registration fee at $100. But after Valentine's Day, $500 to register to study at the MonaK Academy, on top of the registration fees and the course fees for each subject. Right, so you just click enroll to register, and then you enter your credit card information and all that to be able to access the content. Yeah. All right, so I am, as you can see, these are some of the people who have worked with me, and they say all these nice things. Here there is you can either use Google Pay if you have, or you can enter your own credit card here. We have entered some credit card information, that's why it's showing like this, and then you press buy now once you enter your credit card information. So that's about it with regards to the website. So just go there and get your resources. So let's get started, no more wasting time. Like we said, step study system, syllabus. So what does our syllabus say about part B? Syllabus says know. All right, so this is the main objective. Know and use the concept of the factor, multiple, common factor, lowest common multiple, highest common factor, prime and composite numbers. Clear? And then it breaks it down further. Say, okay, list the multiples of numbers smaller than 10. Find the factors of a number. Determine any number in the range 1 to 100 that is prime or composite, and all of that. Right. So what we've done in this sheet is to break down, to take each and every one of these. So for instance, this first one, as you can see, it is right here. So we are going to talk about each and every one of them, do some calculations, and that will be pretty much it to prepare you when it comes to numbers. So let's get started. All right, so list the multiples of numbers smaller than 10. First of all, the question is, what are multiples? Right? Simple. We want all the numbers that are smaller than 10, meaning 9, 8, 7, 6, 5, 4, up to 1. Multiples are numbers in which those numbers go into. So if we firstly list the numbers that are less than 10, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and 9. We just end up to 9 because, all right, I'll just put lines to separate. All right, so what we want is to list the multiples. So what are we saying? Let's start with 1. We want all numbers in which 1 can go into. But you know 1 goes into every number. So all the multiples of 1 are 1, 2, 3, 4, 5, going all the way. Then we go to 2. What numbers does 2 go into? So 2 goes into 2, 2 goes into 4, into 6, into 8, into 10, going on like that. What numbers does 3 go into? 3 goes into 3, into 6, into 9, into 12, into 15. So if in case maybe you say, you know this, that's why it's looking so easy, and what, okay, fair enough. How about if you are not sure, you can use a calculator, right? That's why the calculator is very much allowed. So let's see how we can use our calculator. Let's say 3. So we have 3. We just add another 3. That's now 6. And then another 3. Right? So it's 9. So now if you continue pressing equals to 12, 15, 18, 21, 24, 27, 30, 33. All of those are multiples of 3. Right? Simple. We go to 4, we'll do the same thing. We start with 4, and we add another 4, we get 8. So our 4, we know it's 4, 8. All right, is that enough? From there, we say plus another 4. All Right, so as you can see, once the answer plus 4 comes, now you can just start saying equal to. So remember we said after 8 is 12, from there it's 16, 20, 24, 28, just like that. Okay, so you can do that for all of the rest. We'll just do for 9. 9 plus 9. Because you say, 9 is too big, it will be difficult to do. Alright, there we have, 9 goes into 9, 9 goes into 18. Alright, let's try again, plus another 9, 27. So again, we said once the answer comes in the plus 9, you just press equals to 36, 45, 54, 36, 45. Alright. So it goes on. So those are what we call the multiples of numbers that are less than 10. So it should be easy. It's reminding you of your mathematical tables. I'm sure you used to do those when you were doing your grade 7 mathematics. All right. So very good. That is done. Out of our way. Next. Part of the syllabus says, find the factors of a number. Alright, so we talked about multiples. Now we want factors. So it's the opposite. Right? So when we were saying find the multiples of, let's say, 3, we found the multiples of 3 are 3, 9, 12, 15, and all that. Now we now take the multiples and break them down to find what are the factors of those multiples. So for instance, what are the factors of 12? Meaning, what numbers go into 12 without leaving a remainder? All of them. So finding factors, whether you start doing it now in grade 8 or you started doing it in grade 7, up to the time you do it, okay, I know you won't be able to do it in grade 12, but yes, it will be the same way that you do it, whether it's grade 9, grade 8, grade 10, same way. So what is that way? Simple. You come and put your line here, right? So we are going to do the same. We can even put it on the right. It doesn't matter which side you put it, eh? Do not worry about that. Alright, once we put our line there, we start with the smallest of the factors. So as you can see from our previous question, we have all these 1, 2, 3, 4, 5 up to 9, which are, some of them are prime numbers, some of them are not, but we go in chronological order. We ignore 1. 1 is not a necessary factor, it will come at the end. So let's start with 2, right? On our list there is 2, because we know 2 goes into 12. 2 goes into 12 how many times? 6 times. We know 2 still goes into 6. So 2 goes into 6 3 times. And 3 goes into 6 into 3 once. Right? We want the factors, meaning all of the factors. So we know from this side we have 2 is a factor. And like I said, 1 will eventually come. So 1 is a factor. 2 is a factor. Again, 3 is a factor. Right? Is there another factor that is below 6? So look, there are 2 2's here. If you say 2 multiplied by 2, it gives you 4. So don't forget that 2 times 2 is 4. So 4 is definitely a factor. If you say 2 times 3, you get 6, which is here, which is 6 is a factor. And then after that, only 12. So one of the places where students usually get it wrong is failing to include 1 and cough. You must all include everything from 1 up to the actual number itself. They are all factors. Because if I say, is 12 a factor of 12? Of course. Is 1 a factor of 12? Absolutely. So don't leave it out. You just leave out some marks for no reason. So let's not forget that, right? Alright, let's go to 80. Ooh, 80 seems like it's a big number. Let's see if we can break it down. So like I said, you do not have to worry which side it is. So we start with 2. 2 into 80, you get 40. We go another 2. 2 into 40, it's 20. We go another 2. 2 into 20, it's 10. Another 2. 2 into 10, it's 5. Another 2. 2 into 5, it won't work. So I am going to remove this 2. So I know 2 won't work, 3 won't work, so the only number left is 5, and it goes once. Alright, now let's list the factors. So here I want you to watch very carefully, because all of these ones that we have listed here, they are all factors, but there are also other ones that are hidden. Alright, let's start with 1. So 1 is a factor, 2 is a factor, 3 is not. How about 4? Yes, 4 is a factor. If we say this times that, you get 4. So 4 is a factor. And then 5 is a factor. Is there any way to make it 6? No. 7? No. 8? Yes, I think 8 is a factor, because if we say that times that times that times that, 2 times 2 times 2 gives us 8. So 8 is a factor. So that's why I'm saying careful when they say factors. You're going to see when we're going to deal with what are called prime factors. So it's different. Here they just want all the factors. So some of them will be hidden, especially when you're using this method. 80 is a composite number, meaning it has so many factors. It is more than one factor. That's why it's a composite number. Some of them are hidden. Alright, from there, 10 is clear. 10 is here. 11, 12, 13, 14, 15, 16, blah, 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 blah. 16, yes. Because if you say 2 times 2 times 2 times 2, all these 2's, the 2 times this 2 times this 2 times another 2 gives you 16. So 16 is a factor. And then 20 is clear. 20 is a factor. And then after 20, we know we come to a 40. And then lastly, the 80. So all of those are the factors of 80. So usually a question like this will have a nice big 2 marks. Maybe more, but I think it's just 2 marks. But you can see it's quite an easy process. The more you do it, the more you will be able to grasp it faster. Again, remember, do not forget the hidden ones, especially when the prime factor repeats itself. 2 times 2, 4. As you can see, there's no 4 anyway, but you know it's a factor, right? Now alright, I will not do 120. That will be for you for practice, so that you have something to do. You have seen the gist of what is happening. So we're trying to cover as much as we can for the next 40 minutes. Alright, now the other objective says determine if any number in the range 1 to 100 is prime or composite. Alright, so we have to define prime and define composite. So prime is simply a number that is divisible by 1 and itself. Okay, I think this is self, something like that. So it's a number that you cannot divide another number into it without causing some funny looking digits or decimals or whatever, right? So the smallest prime number is 2. 1 is not a prime number, because look what the statement is saying. The statement is saying a prime number is divisible by 1 and itself, right? 1 and itself. So it means it has 2 factors, the 1 and itself. So 1 only has one factor, which is 1. There is no, so which is 1 in itself, so it's in 1. So 1 is not a prime number. But when you come to 2, only 1 can go into 2, nice, and also 2 can go into 2, so that's a prime number. We go to 3, 1 can go into 3, and also 3 can go into 3, so that's another prime number. We come to 5, we come to 7, so let's just say, as a hint, the first prime numbers below 100, we have 2, we have 3, we have 5, 7, 11, we have 13, we have 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 31, 32, 33, 34, 35, 36, 37, 37, 38, 39, 40, 41. 41 is the prime. Let's test it out. So again, you have your calculator. Is 41 a prime number? 41 divided by 3. There is a fraction there. 41 divided by 4. So as you can see, there's fractions all over the place. So definitely 41 is a prime number. 42, 43 is a prime number. Going on like that, right? So we'll not list all of them. So I'll keep, all right, okay. Let me list them. Let me continue. So from 43, 44, 45, 46, 47. 48, 49, 50, 51. Is 51 a prime number? No, it's not. Let's try again. 51 divided by, let's start with 3. It's 17. So 51 is clearly not a prime number. 52, 53. 53 is definitely a prime number. So 53 here. 54, 55, 56, 57. Is 57 a prime number? Yes, because 3 can go into it. So 57 is not a prime number because 3 can go into it. Stop me. Alright, so 56, 57, 58, 59. Does 3 go into 59? No. So 59. 60, 61. 61 is a prime number. Alright. So I'll end here. Okay, so now determine the following numbers, whether they are prime or composite. So clearly 13 is prime based on our list of prime numbers here. 24 is not, because 24 divided by 2 gives you 12. So there's already 24, 12, there's 4, there's 6. It's composite because it has so many factors. Right. That's how you determine this. 72 and 59, that will be left for you guys to try out. Alright, so when you are trying out, please, I am repeatable. I can be put on pause. You can just pause me, press pause, and then do your thing, and then start opening my mouth. Right? Press pause, work out the question, and then continue. You don't have to worry like, oh, Everson, you've already said it, I didn't hear you. Yes, even if you didn't hear me, you can rewind me. And then I start talking again. I won't get tired. I'll talk and talk and talk. Alright? Let's do that. So You do 72 and 59 yourself, right? Let's look at the next item on our syllabus requirements. Yeah? Find prime factors of numbers and express numbers as product of their prime factors in index notation. All right. So there are very key words that are important here and key in how you present your answer. First of all, we are going to find prime numbers, so it's clear there. We're going to express the numbers as products. So we're going to express the numbers as products. We know product means multiply. So we're going to express the numbers by multiplying its prime factors. Multiplying its prime factors. And then lastly, it has to be in index notation. So all these things that I have underlined are key in how we're going to present our answer, right? But that doesn't make it difficult, it's just key, right? So we take the approach that we took when we're doing factors, yeah? We just divide from this time again with prime numbers. So our smallest prime number is 2. 2 into 28, it's 14, great. 2 into 14, it's 7. 2 won't go anymore, 3 won't go anymore. Remember, 7 is part of the prime number list. Just move the page up or rewind. You will be able to see. So 7 and 7, 1. So how do we express 28 as a product of prime factors? First of all, you come and say 28 equals to 2 times 2 times 7. But although this is a good expression as a product of its prime factors, it is not in index notation. So now we have to put it in index notation. So how do we do that? We check, are there any prime numbers that are repeated? So here clearly we have 2 is repeated. So how many 2's do we have? So in index notation, 28 is, how many 2's do we have? We have 2 of them. And 7 is only 1. Now that is 28 expressed as a product of its prime vectors in index notation, the second part, where 2 to the power 2 times 7 to the power 1. Alright, we want proof. Can we do that? Alright, 2 to the power 2 times 7 to the power 1. Does it give us 28? Of course it does. Excellent. So we try out, let's try out, we'll try 124. We'll leave 32 for you. I will say this is for you. Let's share. Yeah, we have to share. I'll do that one and I'll do 124. 36 is too cheap for you, man. Eh? Yeah, I think once I do 124, everything is done. All of these are for you. Yeah, I'm not greedy. Have at it. Alright, so let's start with 124. So again, our line. We have our 2. 2 into 124. So we know it's 6, 2. If you are not sure, go and use your calculator. It's good to teach your mental, right? But if it's slowing you down, come on guys. If it's slowing you down, just go get the calculator. Don't even feel bad or feel like, yeah, calculator. Because you're allowed to use it anyway. So, come on, why not? Use it to the fullest. Alright, 2, it's 3, 1. Ha. If you remember correctly, up there, 31 is right here. So nothing else can go into 31 except 31. So we reach a dead end, so it's 31, which is ones. So now we express 124, which is 124 equals to 2 times 2 times 31. But again, like we said, it's not yet in index notation. So when it becomes index, it becomes 124 equals to 2 to the power 2 times 31. Nice. Okay, I think I'll be a bit lenient-ish and do one last one, since that one seemed to be quite short. Right, let's try 42. 2 into 42, you get 21. 3 into 21, you get 7. 7 into 7, you get 1. All right, so 42 equals to 2 times 3 times 7. So as you can see with 42, there is no prime number that has been repeated. So it's already in index form. You can't say 2 to the power 2 when there's only 1 2, or 3 to the power 2 when there's only 1. So only when you have the repeated, and by repeated I don't mean only 2. If the 2's are 4 of them, you're going to have 2 to the power 4. So for instance, if we go back to 80 here and write it as a product of its prime factors, it will be 80 equals to, how many 2's? 1, 2, 3, 4. 2 to the power 4 times 5. Just like that, we can prove it in our calculator. 2 to the power of 4 times 5 gives you 80. Alright, so that's how you write product of its prime factors in index notation. So that should be it. Then we move on to the next. Right. So we're going to lowest common multiple and highest common factor. Alright, so before we go on to that, I just want to remind and thank all our excellent sponsors who are making this possible to reach you. Check them just down there. You see their logos are just moving up and down there. All right, let's start. So determine the lowest common multiple. So remember when we started, we talked about multiples, which means numbers in which other numbers go into. And we took the highest common factor, which are the numbers that are going into the others. All right. So we want lowest common multiple. So with multiples, it has to be the lowest one, because let's say you have a number 5. How many numbers does 5 go into? 5 goes into so many numbers. It goes into 5, it goes into 10. There is no ending to numbers which 5 goes into. So you always want the lowest. When it comes to highest common factor, let's say what is the highest number that goes into 24, right? So obviously you want the biggest possible, except the number itself. Come on, then it will defeat the purpose if we use the number itself as a factor. Any other number except itself, but the highest possible. So let's see. Determine the LCM and the HCF of the numbers in each case. So LCM, lowest common multiple, HCF, highest common factor. Great. We start with LCM and then we go to HCF. Now what you must know is the approach is going to be exactly the same that we were doing when we were doing prime numbers. And it will bring us answers for both the lowest common multiple and the highest common factor. So let's see how that works. So what you do is you come and write your numbers down. So we want the LCM of these 3 numbers. So in your exam it can be 3, it can be 2, but I know for grade 8 maximum 3. So let's go 24 there. We break it down. 2 into 24 is 12. 2 into 12 is 6. 2 into 6 is 3. 3 into 3 is 1. Alright. We go to 28. 2 into 28 is 14. 2 into 14 is 7. 7 into 7 is 1. And then lastly we have 42. 2 into 42 is 21. 3 into 21 is 7. 7 into 7 is 1. Alright, once you have this, let's just make it shorter. Once you have this, I want you to come and rewrite those numbers nicely arranged. So we start with 24. We know 24 is 2 times 2 times 2 times 3. 28 is 2 times 2 times 7. And lastly, 42 is 2 times 3 times 7. Alright. So, I'm going to borrow space from this part B here, just to finish up our calculation, because there's not enough space. Now, once you have things arranged like this, let's start now with the lowest common multiple. So for LCM, this is what you do. For LCM, you want to look at each and every one of the prime factors for all the numbers. Let's say you look at 2, you look at 3, and you look at 7. Those are our prime factors that we have, right? So now, where do we have the highest number of 2's? Okay? The highest number of 2's. Let's start with 2's. So the highest number of 2's, they appear in the number 24. And 24 is how many 2's? 3 of them. So that's the one you choose. You choose where the prime number appears the highest. So in 28 there are only 2 2's. In 42 there's only 1 2. So we know the highest number of 2's is in 24, where it is 2 to the power 3. Then we multiply by, we go to 3. Where are they the highest number of 3's? In 24 there's 1 3. In 28 there's no 3. In 42 there's also 1 3. So we just take 1 3. And then lastly, we look at 7. Where are they the highest number of 7? There's only 1 7 in 28 and 1 7 in 42. So 7 to the power 1. So once we have that and multiply in our calculator, it will give us our lowest common multiple. So let's take advantage of it. 2 to the power of 3 multiplied by 3 to the power of 1 multiplied by 7 to the power of 1 again. You have your 168. So your lowest common multiple is 168. What does that mean? It means 24, 28, and 42. All three numbers, they will go into 168 without leaving a remainder. Magic! It's not magic. Let's see. Let's see if the calculator is telling the truth. So 168 divided by, we start with 24. Nice, no remainder there. 168 divided by 28. There, no remainder there. 168 divided by 42. Excellent. So you see all the numbers, they go into 168 without leaving a remainder. So 168 is the lowest common multiple of the three numbers that are given. Now, we also want the highest common factor, which means a number that goes into 24, 28 and 42 without leaving a remainder? Is there such a number? Let's wait and find out. So now, when it comes to multiple, we use to factor, we use the black. So with the factor, unlike with multiple where we're choosing where there is the highest number of the prime factor, here it's saying highest common factor. So we want a number that is common across all three if there are three, or across all four if there are four, or across all two if there are two. Here is 3. So what is common? So 2 is common because we have a 2 here, we have a 2 here, we have a 2 here. So 2 is common. Do we have another 2, 2, 2? No, we only have a 2. There's no more 2s on 42. So 2 is gone. How about 3? 3 is there here, but it's not there on 28. So 3 is not common. How about 7? 7 is on 42. 7 is on 28, but 7 is not on 24. So 7 is also not common. Therefore, our highest common factor is simply 2. Done. Meaning 2 is the only number, the highest one, that can go into 24, 28 and 42, all three, without leaving a remainder. If you choose any other number, it will definitely leave a remainder. Very simple, right? Alright, so again, if I may have moved fast or something that you missed, take me back by rewinding me so that I start talking again from where you got lost. You can rewind me over and over and over and over and over. Okay, that's enough. You can rewind me as much as you want. That's the beauty about this. Let's try. Let's see B. B is small numbers. Okay, remember we share. So I'll take D and then you do B and C. Again, same story, same process. This time I will try to make things fit now. So we start with 18. 2 into 18 is 9. 3 into 9 is 3. 3 into 3 is 1. Alright. We go to 30. 2, you get 15. 3, you get 5. 5, you get 1. We go to 45. 3, you get 15. 3, you get 5. 5, you get 1. Alright. We remove the long lines. We come and rewrite. We know 18 is 2 times 3 times 3. 30 is 2 times 3 times 5. And 45 is 3 times 3 times 5. Nice. So our LCM, as usual, we said we want each and every prime number. So we start with 2. 2, we only have 1, 2 on 18, 1, 2 on 30. So 2 is just 1. So 2 to the power of 1 times. Our 3's, they are the most at 18 as well as at 45. They are just 2 on each. That's the highest. So 3 to the power 2 times 5. 5 only appears once on 45, once on 30. So 5 is 1. So LCM, we use our calculator. Yeah. Where is it? There it is. Alright. So 2 to the power of 1. Remember, any number to the power of 1 is just that number. I'm just putting so that you don't say, no, but how come you did not put? Okay, you don't have to put, no, this is 2. You don't have to put the 1, the power 1, because it's just going to be the same. but let's just put it for clarity's sake. So our lowest common multiple is 90. So what does that mean? It means all the three numbers, they go into 90 without leaving a remainder. Again, we test it out to just prove, and also to confirm. When you are doing it yourself, just use that to confirm. So 90 divided by 18. I don't have a remainder. Great. 90 divided by 30. I don't have a remainder. Great. 90 divided by 45. I also don't have a remainder. So that is it. Again, we said using the same calculation, we can do the HCF. So highest common factor. Right, so we want a number that appears on all the numbers. 2 only appears in 18 and 30, so 2 is out. How about 3? 3 is there, 3 is there, and 3 is there. So 3 is common. Is there another 3? Yes, there is 3 here, but there is no more 3s. 5 only appears here and there, and it's not common there. So it has to be common. So which means our factor is simply 3. Right, so just in case, let's say, so this is the answer for part D, but just in case, since it did not show on our calculations, what about if it was, let's see, if it was, it was 2018 as well as, yeah, if it was just 30 and 45. If it was just 30, so remember 30 is 2 times 3 times 5. What about if it was 18? Yes. We have 2 times 3 times 3. Alright, so if we wanted the highest common factor here, we're going to have 2 and 2, they are common, which is 2. 3 and 3, they are common, which is times 3. No more, which are common, which makes it highest common factor being equal to 6. Alright, so in case, since our calculation, they seem to just add one factor, so in case, as long as they are more common, you keep doing it. So which means if there were more 2's, right, you're going to cancel 2's. If there's another line of 2's that is still common, you put it. If there's another line of 2's that is still common, until they are all, there's nothing else that is common. Alright, any questions in the link, or send them through my WhatsApp number, as you can see right here, the WhatsApp to the MonaK Academy, 0853155844. Yeah, you put that number in your phone, connect to the MonaK Academy WhatsApp, send any question you have so that we can attend to it in our next lesson. All right. Okay. I hope we've not, hey, it looks like we are about to exceed our time, which is, okay, we won't take a break. We'll just do our two lessons according to the, no, it's supposed to be 40 minutes. Okay, so we will continue with the basic operations in our next lesson for grade 8 mathematics. If you love this video and you want to continue with me for the rest of the year or the rest of your high school life, please click subscribe on the YouTube channel and smash that like button so that the video can help a little bit with the algorithm for YouTube. and share with your friends who are doing the same subject, right? And like I said, I need your collaboration, I need your input so that I know where you are still having struggles, right? And again, rewind me as many times as you want. All right? See you tomorrow when we are doing accounting. If we're not doing accounting, then check the timetable. You will see me on Thursday again for a grade 8 mathematics class. We will continue with this and we see when we start another topic. Now, I understand that a lot of our students do not have calculators. Okay, I've shown the calculator that I'm using, which is the calculator emulator. More than 50% or even more of our students in public schools do not have calculators. So the MonaK Academy is starting a calculators and mathematical set fund. So by joining through our WhatsApp group, you automatically be entered and stand a chance to win a calculator or a mathematical set. Now the way we're going to work with the calculators is this. We want this to keep on giving, meaning we'll lend you a brand new calculator, you use it for the year, and then you bring it back. Unless you are continuing with your mathematics, then you continue using it. Until you are done using it, then you bring it back. So take care of it like it's yours if you get a chance to win the calculator. So how do you win the calculator? Every Saturday, we are going to be having live classes. So check on the timetable, what time is your grade 8 class. So during that live class, I'll be asking the live participants different questions, and then they can be able to win their calculator. So see you in the next lesson. Hit subscribe. Bye for now. Novax Date signing out.